So it's possible to have arrays of objects. That's something interesting to observe, just like it's possible to have arrays of primitive data types, integers, doubles, and so forth. Just a quick digression into this little topic of function default parameters. I would actually discourage you from using it. I'm not using it in my code. But here's the idea. If I want to define a function named print, and I'm not going to spend any time coding it or anything, just giving you an overview, just a quick overview of what default set of parameters is. You can say that I want to be able to call this function with all parameters, like value and base and print it, right? But I also would like to be able to call this function with like abbreviated set of parameters. And for that, if I do this, print 31, just assume that the base that I want to use is 10. And this is obviously like radix base, numbers, like decimal numbers, octal numbers, or maybe hexadecimal numbers if base is 16, something like that, right? So, so the syntax is very simple. Well, if you want to have a default value for this parameter, simply say equals whatever. So it would be the same as defining those two functions separately. One would take just one parameter, another one takes two parameters, and from here simply say, okay, just rewire it and use this default 10 parameter and just delegate the call to this other version of print, which takes two parameters instead of one, right? So this syntax is permitted. But only the trailing arguments can be defaulted. For example, if I say function 1 takes x and y has a default parameter or default argument, then function 2 I also want to structure like this. No, that's not gonna work. This is only trailing parameters can be allowed to be specified having default parameters. The reason for that is that this can terribly mislead the user of your function, right? Because in one case they want to call this function, okay, and pass x. In other case they want to pass y, or they think that they're passing x, but for some reason you're saying, oh no, I want to default the first parameter. It just doesn't really work that well from the simple logic standpoint of a caller, right? So this is not allowed. Only trailing parameters can have default arguments. So when we say let's declare a function, we give a function signature, and then we also create function definition. Originally, the declaration could use it, and then also the definition of the function could also use the default parameter, simply to make life of a programmer simpler, I suppose. So you can copy and paste the declaration into the implementation file and define what function does. Nowadays, this is not allowed. So the current standard no longer allows to repeat the default parameters. So you have to use like an inline comment if you want to keep this default parameter in view when you're coding the definition of your function. We're actually defining what the function does. All right. Dynamic memory allocation we already covered, which is great news for us. So we said that let's just kind of summarize what we were already talking about today. Great deal. So dynamic memory allocation. Two forms exist, new int or new int and specify how many. Those are two forms of new. So you can create a single object dynamically, or you can create an array of objects dynamically. So new and delete are keywords. Remember that you have to use this very specific version of delete for arrays. Otherwise, you're actually corrupting the free store. Official C++ dynamic memory manager is called free store. In C programming language, it's called heap memory, more often referred to as heap memory. In C++, it's anything that is done through new and delete is referred to as free store management. All right. So if not enough memory, new returns back null, which is simply defined as 0, just like memory address with all zeros in it. And then attempting to delete a pointer which contains a null memory address is harmless. So that was decided earlier on, and that's the case. So some examples here. We went over this today quite a bit. Destructors, very curious. Like we mentioned a lot of business related to constructors. What about destructors? In our case here, our integer stack right now have been somewhat changed so that it starts to use dynamic memory, right? We said, okay, so look at this constructor right here. It says new. That's where the storage is allocated. As soon as the object is constructed, somehow we know what initial size to use, and we say new and use initial size to say, give us this many integers. By the way, just a note, which I don't know if I told you already or not. As with arrays and the free store memory allocation like this one, it's guaranteed that the chunk of memory which will be used is not going to be fragmented. It is guaranteed to be sequential block of memory, right? So all integers are sequentially placed in there, right? If there are two chunks of memory and you cannot fit into either of them, the new will fail. It's not going to work. Sometimes, if you're not careful, by using new and delete excessively, you could actually fragment, just like you can fragment your disk space, you can fragment dynamic memory. And although you're returning memory, it's kind of somewhat special case. But just to give you an idea, that there are cases when new and delete fragment memory, and then you try to allocate bigger chunk, but there is no place for it because it wasn't managed properly. It actually does happen more often in embedded systems, which sometimes use the very primitive types of implementation of free store. So it's kind of interesting. So we do have this dynamic storage. It's part of our life. We start with it right here. So then, when this object goes out of scope, maybe, just maybe, we want to deallocate that memory. We know delete will work, right? We only need a place to put it in. So guess what? So oftentimes I actually comment as this: constructors and a destructor. Destructor is the opposite side of the constructor, and its syntax is like this: is a bitwise not operator. It's used in C++ to indicate that this is a destructor. Okay, so just like the name of the class corresponds to the name of the constructor, the name of the destructor is the same, only a little tilde is used in front of it. So therefore, this is how I can define my destructor. Control C and just say, all right, in front of this name there is a tilde and there is a destructor, and guess what my destructor could do? I'm not analyzing all possibilities here, but just as an example, say delete. Don't forget square brackets and delete this. Give it back, right? So now look, if I decided to create essentially 100 integers, an array of 100 stacks, and I'm trying to, I think my drive went to sleep for a while, and it just takes time for this to wake up. Okay. I'll wait for this. I'll just talk about it. So when you define a destructor for every object, when it goes out of scope, a destructor will be invoked. And therefore, I will be very happy with this portion right here, so that I will, so that the memory will be returned back to the system. One little workaround for delete is that it is guaranteed and supported by the C++ standard, that it is okay if we have like a little batch program that just starts, does 1, 2, 3, 4, 5, steps, and exits entirely. Then you probably don't have to call delete, because exiting the program normally guarantees that all memory is returned back to the system. So in that case, if you're writing just a small procedural type of thing, and it does 1, 2, 3, 4, 5, and you exit, and you've used new many times, you don't have to worry about delete. But as soon as you think about a program that runs someplace in the background, that stays in memory for a long time, for example, like an internet browser, right? User could never shut it down for like 2 weeks. You probably don't want to leak memory from there, because very quickly it's going to run out of memory, exhaust all memory, and become dysfunctional. So that is a big issue. And another example would be some sort of a server program, like web server.